To the introduction, we have two speakers from Bharat Forge, Mr. Chethan, Group Director, Quality and Excellence Champion, Kalyani Group of Companies, Pune. Chethan has been in this role. Chethan has been in this role for the last 10 years, primarily driving world-class quality and excellence initiatives across all Kalyani Group of companies, bringing high degree of customer centricity in the organization. He has 30 years of experience in various areas such as R&D, engineering, quality assurance, manufacturing operations, operational excellence, Six Sigma in steel, automotive, general engineering industries. The next speaker from Bharat Forge is Praful, Manager IT Services, leading Industry 4.0 deployment at Bharat Forge. He has 11 years of experience in industrial and systems engineering, manufacturing engineering, product management in automotive MNCs and auto component industry. I request both Chethan and Praful to come on stage, please.
Good afternoon, everybody. First of all, I would like to thank Mr. Ganapati Raman and ARC Foundation for giving us an opportunity to share some of our experiences and thoughts in the field of IIoT implementation, specifically in the steel industry. It's indeed a matter of great privilege for me and my colleague to be here and share what exactly we have done and what are the success stories we could come across. Before we get into the case study, I would like to give a brief overview of our company in terms of what we are doing and what is the relevance of IIoT with respect to the corporate excellence initiative that we have launched in our company. And this excellence initiative is the one which is helping us to grow both the top line and the bottom line. And that's the mantra of what we have been doing, and that is what is going to drive the organization moving forward. Just to give a quick overview of the company, I'll be covering four things. What are we doing as a group, and what is the backbone of excellence system, and what are the pillars and tools. Then how exactly one of the tools, that is value stream mapping and IIoT, have been integrated in our company. And then the last is some specifics on the case study with reference to one of our production units. This is a quick overview of what we are doing. There are four key product segments. The first one is engineering steels. The second one talks about forgings for various applications. And then third is automotive components. And fourth is energy and infrastructure. There are totally 16 plants spread all over India and primarily in Europe. We are yet to put new footprints in US and China, but these are the 16 plants catering to various customers, covering all the product domains that I explained now. In terms of market position, from a forging perspective, we are the largest forging company in the world. And in terms of the auto components, we are the largest supplier of chassis and engine components, right from the smallest to the biggest engine that people make. And then we are number one in engineering steels in India in terms of diversity, complexity, and the criticality of the application involved. We are number one in axle aggregates, primarily due to the manufacturing facility we have at Mysore. And then we are number one exporter of wheels for various off-highway and highway vehicles. Talking about the footprint from a global perspective, primarily we have manufacturing facilities in India, in various parts of India, and then in Europe. And our combined capacity is something like 565,000 tons per annum. And this is primarily to take care of various global customers. From a product overview perspective, 62% goes to automotive industries, both the passenger car, commercial, and off-highway and military vehicles. And then, 38% comes from industrial products, which covers oil and gas, energy, aerospace, railways, and construction. So this is how the product portfolio is distributed. Talking about the mantra of excellence, we started this process about 5 years back. The whole objective is to achieve excellence in everything we do, right from the human resource function to the sales function. And this is what is helping us to stay fit with the competition growing and the profit margin shrinking. So this is what we believe, and this is what we do every day. So primarily it has 5 pillars: the people engagement process, the performance management systems, operating systems, engineering systems, and customer satisfaction management. This is a dynamic process, and every year we keep calibrating this model as we keep learning lessons with what has gone wrong and what we learn from new business opportunities and what we learn from new customers. So this is a dynamic model that goes through calibration. Like any initiative, there are specific tools under this initiative, and the specific tool which is relevant to IIoT is value stream mapping. That's what we see here. In simple, value stream mapping, as you all know, it's a tool for doing more with less, eliminate the waste in the system, and also that's something that helps to increase velocity in the organization. That is how we have defined value stream. And one big difference is that we do value stream mapping not only in manufacturing, but in every process, right from a human resource process, financial process, engineering process, etc. So we have really used it to the full potential as far as the power of the tool is concerned. Now, this is just to tell you, we did about 22 value stream mapping exercises covering various functions, both manufacturing and non-manufacturing, and that is how we could generate a lot of ideas for improvement in terms of waste elimination and increasing velocity in the respective function. Now, coming back to value stream mapping, it typically talks about three things. One is a material flow that covers quantity mode, distance mode, and time. As far as information flow is concerned, a conservative value stream map talks only about the medium of information flow, whether it's electronic or paper-based or some other means. So what we have done is we have strengthened the value stream map using two more aspects. One is, what are the media breaks happening in the communication process? What are the media breaks happening in information flow, which is very important in the organization as you get into a growing business, especially with multiple sites, doing business with multiple customers. And second thing is, what is the scope for digitizing what you do? So these are the two additional things we try to cover in value stream mapping and identify all those hidden potentials for addressing that activity. This is how a typical value stream map looks like. I don't have to explain what it is. What we have done is, you can see something at the bottom here. We looked at all operations in terms of what is the information we are generating. Somebody talked about the data getting converted into information and then information aiding the intelligent decision-making process. So something very similar to that we try to do. What are the kind of reports, how many reports we generate, and what's the total number of functions involved, and then approximate time required for each function. So we try to do an industrial engineering analysis. Then the maximum time consumed or spent for the report, because there could be one bottleneck report which is very important for decision making. And then number of people and functions involved in all these transactions, and number of agencies to whom this is communicated. It's a very complex process as you start mapping. So this is the difference we try to bring into value stream map, which is normally not done. So after that, we started analyzing this data in terms of what we can do to kill the waste. So we followed simple methodology of ECRS, which is nothing but eliminate, combine, rearrange, and simplify. It's a very simple tool, but very powerful tool to kill the waste in the organization. And that is how we could integrate Industry 4.0 and value stream map. So value stream map provides the input and IIoT gives the solution. Now I request my colleague to take over and continue talking about this topic.
Yeah, so good afternoon everybody. This is the scope which we have decided for our Industry 4.0. It is about creating smart connected enterprises, eliminating media breaks. Media breaks are, as we defined, wherever there is a manual intervention required for collecting, processing, transmitting, or reporting any kind of information. So eliminating media breaks, when we do that, we have real-time OE monitoring, automated dashboards tracking several reports and KPIs, real-time equipment and process monitorings, quality monitoring, running real-time SPCs, and also based on all of this, the alerts and escalations built into it over mobile and emails. And when we have enough amount of data, we should also be able to do predictive analysis. And that's how where we connect robots over forging lines, augmented workshops, shop floors, measurement systems, our machines, conventional and CNC machines, our ERP system, SAP, all of this over a big data or cloud, and then enable visualization of all this information and make it mobile and provide it to the management, so that we have smart connected enterprise. These are the lean principles on which our industry 4.0 is based on. It is driven based on lean principles as design basis, eliminating our media breaks, having cyber physical systems where assembly assistance systems are provided on the shop floor, human technology cooperation in the processes, mobile standardized interconnected labors where the information is available not just to one specific person but also all the stakeholders involved in that process, and bringing real-time data transparency so that data is not just in one machine, one computer, or with one report. We have decided 5 building blocks on which our industry 4.0 journey will be built on. The first is all the information which flows from top floor to the shop floor will be online digitized. Second is all the information which flows from shop floor to the top floor will be again digitized and made real time. Based on these 2 flows of information, it will be visualized. So visualization will be built over this set of data. So top 3 are typically when we talk about industrial IoT. There are other 2 building blocks, which is digitization of material flow and digitization of services, which are enablers which adds context to the data which is generated at OT and IT integration with top 3 blocks. So I'll present a case study on one of the forging lines where we have done the implementation of industrial IoT or top 3 blocks, the information flow from top floor to shop floor to top floor, and visualization of the data. So this is a 10,000 ton forging line where we primarily forge crankshafts and axle beams. The process is we get the bars. Bars are cut into cut to size billets. They are heated to around 1200 degrees Celsius. Then they are descaled. It goes through a preforming operation called reduce rolling, then a blocker operation, a finisher operation. After that, the flash extra material is removed, trimming, and then padding to realign the geometries, and then control cooling. So this is the process flow for the forging line. What all KPIs we monitor on this line is OE, equipment utilizations, productivity, material input and output count, so reconciliation of that count, how many billets were fed into the line, how many were the dropouts at what stages, and what were the final output number, and also the SPC, the product quality measurements. There are number of reports which are generated. There are about 7 BFL excellence charts which are generated daily. In every shift, 5 reports, so 15 reports are generated. All of these are on paper. Operational charts, quality charts, several of them. The measurement which is taken on the quality bench after the forging comes out at the end of the line. So all of that measurements are manually done. Machine health reports, audit forms. There are 4 audit forms: layer audit 1 and 2, and then several machine audit forms. 21 guidelines and daily operator tasks, 19 of them. So all of this covers up the complete gamut of reports and information which flows from top floor to shop floor and shop floor to top floor, which we have got it on a single system and made it online. This is a general architecture of our line, where all the machines, starting from the billet cutting machine to the final cooling conveyor, is on a shop floor network. Now our shop floor network and office networks are totally separate networks. There is no communication between them, primarily because of the security and safety of those machines. So office network doesn't talk to any of the machine networks. That's why what we did was we put in an intermediate computer which will read the data tags available from the main press line, which has got the master controller and is connected to all the other machines. So this central computer reads the information from the master controller and releases it to our data center. So data center is protected by firewalls. So all the information which comes in and goes out is very much controlled. And then over it is the complete visualization and reporting layer is built. And then we provide reports. We'll have a look at several reports to all the stakeholders. Now stakeholders are the control panel room, the person who is running the line, to line supervisors, to the shop floor manager, and to the top management. So we have placed large screen dashboards in the line and also provided touch screens to the control panel operator. primarily only the touch screen is the where he only do the qualification of the downtime. So he gives, if the downtime is in there, what is the reason which is contributing to downtime. That is the only input he gives. So today the manual entry on all the forms, so the 5 reports and 19 dot forms and all the downtime report forms are eliminated, and all of that is now online. Currently, we are also trying to remove all the other reports currently, because all of them are printed on paper and then displayed on the display areas in the line. We want to eliminate all of those input screens so that the reports can also be, which are shown, are live on the dashboards on the shop floor. What we do is we collect about 60 parameters from the master controller. Those are 2 types of parameters. One is machine health parameters, so where we capture the temperatures for the bearings, the lubrication cycles, and process parameters, where for the line performance parameters, where we capture how many billets were fed into the line, how many billets were coming out at the end of the line, what were the temperatures for each one of those billets, to what temperature they were heated, and what forces at which they were forced. So for each billet, we are capturing all of that information in real time and generating all the reports and dashboards which we saw earlier. So an executive dashboard which is shown to the top management, it shows whether the line is up or down. It shows for the last 24 hours what has been the performance of the line, showing also the trends of the APQ and OE, total number of parts produced, and also for the last 1 hour, the temperature trend. So how the temperature trend has been for all the billets which are coming out. It also shows on the dial gauge the last 24 hours performance in APQ and the OE. Along with it, it provides all the analytical reports which are required by the shop in charge. So it shows for the last 7 days what has been the APQ, what has been the performance of the line, what has been the Pareto of the downtime reasons. It also shows the die-based performance. So this is available for 90 days, where we can deep dive from quarter level view to an day level view, and for 7 days, where we can deep dive again 3 levels to an hour level view. So we can deep dive to a very specific what hour, what dies were forced, what parameters were there, at what temperatures they were forced, what was the machine setup for the forces. So all of that is available. And so this is the die-based performance reports, where it shows how many parts, OK parts were forged, how many parts were dropped out, at what locations they were dropped out. So what was the reason for those, what has been the cycle times for those reports, and also it at the end shows the OE utilization and what were the contributing factors for losses. So what contributed to what losses. This enables our maintenance and production teams to focus their actions on reducing the contributing factors. And the machine health parameters, which it will be good to have. So in machine health parameters, it shows the trend of each of those parameters. So machine maintenance in charge has always a real-time view of how the lubrication cycles have been functioning over a period of time, or how the temperatures of the bearings have been. And if anything goes out of the range, it sends an alert to him that temperature of the bearing for this duration has been out of range for last 30 minutes. So please go and have a look. And moreover, he can select 2-3 associated parameters which he know are contributing to the overall performance. Like if the lubrication cycles are low, that may result into the increase in the temperature, or may result into the lesser forces being experienced at the forging time. So he can cross map all of those and generate his own reports and analysis based on his understanding of the process. So this is another chart where it shows the last 90 days of performance, showing what all dies were forged, what all parameters were used to forge them, and we can deep dive into each one of them. So this is another view of the same report. What we have been able to do, the benefits which we have been able to achieve. So as this is a work in progress project, we are still learning a lot of things, but few of the things which we have been able to achieve is eliminate a lot of manual data gathering and reporting. So it has effectively eliminated about 2,000 hours of manual work annually. It has increased data integrity and availability, because earlier whenever there is a manual entry for what was the duration for the downtime, there is always a question whether it's a correct record or not. Now we don't have such questions. It also enables us the real-time OEE monitoring. So anytime anybody can, who is enabled, can go and see what is the OE and what are the contributing factors for OE not meeting a target. It shows the equipment and process parameters in real time, and also enables faster responses if a situation arises where none of the means any of the point is out of control range. It also have the quality monitoring. So we also at the control bench, all the quality parameters which we measure are also going to the same system. So we are capturing the quality parameters against the production batch. And SPC is also built over not just the quality parameters, but also all the process parameters, all the forging parameters. All of this can be used, SPC analysis can be done on each one of those. It also has email and mobile alerts. Also are escalations built into them. Predictive analysis. Currently, we have just been 3 months where we have started using this. Once we have enough amount of history, and it will allow us to do a kind of a signature building of each of those processes, and eventually we will be at a stage where we will be able to do the predictive analysis of all the parameters which we are capturing. And moreover, it also allows historical or retrospective analysis of any event. So if there is a question about a part going in the machining, and question comes from the machining shop, okay, what were the parameters which we used to machine this, because they are seeing something which is not usual. We always have all the history available for each billet, and that is a very, very strong point where we know what we did and what was the final result in the machine shops. So other than industrial IoT, two of the other enabling building blocks is the digitization of material flow, where the material flow, where challenges in forgings are because the parts are at 1200 degrees Celsius, nothing survives on it. So that's one challenge which we are currently dealing with, finding out how we will track each billet from forging till the machining where it gets finally shipped, and also the die tracking. So currently we are implementing one of the projects for die tracking. Digitization of services are various services. All of those services are the enablers of all the production which happens. So engineering processes, quality processes, all the administrative processes, those are also several projects we are running, which are, though not purely industrial IoT, are enablers of industrial IoT to happen. So those are the 5 building blocks under which we are doing several projects. And from the first industrial IoT project, or Industry 4.0 project, is our learning project. We want to learn from this and incorporate this learning into the project, and then enterprise-wide deploy Industry 4.0. And that's the roadmap for our Industry 4.0. Thank you for your attention.